Hi, I am Varun Joshi and welcome to day 55 of our Certified Kubernetes Administrator 2025 course. In today's lecture, we will be upgrading Kubernetes using kubeadm step by step. Before we touch the cluster, we will cover versioning and release cadence, support window and real world practices, skipping versions and sequencing, version skew, which is component compatibility. Then finally, we will move to the upgrade section. We will upgrade a multi-node Kubernetes cluster with kubeadm control plane first, then workers, one at a time using Cordon, drain, and verifying everything works as expected. We aim for minimal disruption, but we do not promise zero downtime upgrades, especially for stateful apps. And we will look into why I am making this statement. We will do this demo on cloud VMs provisioned in AWS cloud, but the exact same steps work on any VMs, be it in your home lab, on premises, or any other cloud provider. Just ensure the image, the operating system that you are using matches mine, which we deeply discussed in the previous lecture, that is day 54, where we created a multi-node cluster running version 1.32, and today we will be upgrading that cluster to 1.33, which is the latest release by the Kubernetes community. With that understanding, let's get started with this lecture. In this lecture, to cover the theory part, I will be using GitHub notes because there are few nuances that I want you to be aware of before we start with the actual demonstration. So let's go to the GitHub notes of day 55, and here I am, and these are the theory topics that I want to cover. In the introduction section, I want you to concentrate on this step where I am referring you to day 54. In day 54, we created a Kubernetes cluster. If you do not have a Kubernetes cluster, then what will you upgrade? Keeping that in mind, ensure you have a working cluster with you before you start with this lecture. And please do that because I want you to run the commands with me step by step so that you have a real-time experience. Do not just watch the video and think that I'll do it later. This demonstration can act as your runbook when you are actually doing production upgrades. So stay with me and do the demo along with me. First is versioning and release cadence. Nomenclature major.minor.patch. So whenever we are talking about Kubernetes version, we say we are running 1.32.8, and this is the version that we installed in our previous lecture. So 1 here is the major part, 3.2 is the minor part, and patch is the patch release. Patch releases are typically to introduce some bug fixes or security fixes. Minor releases introduce new features, and 1 is the major release, which has been constant since the inception of Kubernetes. So 1 has not changed. What you will see change is the minor version and the patch release. The frequency of minor releases is typically every 4 months. So you will have 3 releases approximately per year. Patches are released typically on monthly basis. Now, why this matters? Plan an upgrade window roughly once per minor and expect early patch drops soon after you move to a new minor version. I want you to know, when you are dealing with production environments, you will not be running the latest version at all times. You would typically be working with n-1 or n-2. But you must keep in mind that Kubernetes, the upstream Kubernetes, only support 3 versions. So if right now we are on 1.33, then the Kubernetes community will only support 1.33, 1.32 and 1.31. So as soon as 1.33 was released, 1.30 was deprecated, as in it was not supported by upstream Kubernetes. Implication: if current is 1.33, only 1.33, 1.32, 1.31 receive security bug fixes. Plan upgrades accordingly, which is why I am saying when you are dealing with production environments, you will typically be using N-1 or N-2, because if you are running a version that is not supported, then you won't be receiving security updates or bug fixes, and this is critical in production implementations. Your security teams, your DevSecOps teams are concerned about what versions you are using, whether they are in line with industry best practices or not. But here is a caveat. Cloud providers are typically liberal in this scenario, and they charge you a fees for being liberal. So for example, if I talk about Amazon EKS, you have an extended support. So I will let you check the documentation for the respective cloud provider so that you can see what is the support matrix for your respective cloud provider. I have attached all the links in the references section of this repository, so do check it out. Now let's see some production insights. I want you to take this with a pinch of salt, because this is subjective. This is subjective to the project you are dealing with. Maybe you have to ensure that you are always running N-1. In that scenario, you will be upgrading your cluster every 3 to 4 months. I'm talking about the minor release right now. In some scenarios, you would be upgrading every other minor release. So if you are on 1.31, you might not be upgrading to 1.32, but you will be upgrading to 1.33. Again, this is subjective, but even if you are running 1.31, you will still be updating your patch release. Patches must be the latest. You must be running the latest security patches in order to ensure you match the upstream Kubernetes. That's one. Second, to keep your security teams happy. Here is an important point. Prod rarely jumps to brand new N, which N implies the latest version. Even if you are on N, it is usually not the day 0 latest patch. You will wait for follow-up. For example, right now 1.33.4 is the latest version. You will not see production grade implementations using that version, because it is the latest version first, because it is the latest minor release, but it also has the latest patches. So in production, you will not see such scenarios. But again, if you spot N with the very latest patch in production, then do let me know, because I am yet to see a production implementation which is running the latest minor release along with the latest patch. But in today's demo, we will be going to the latest minor release along with the latest patch. Now, this is an important point. Skipping versions and sequencing. So if you are on 1.31 and you want to go to 1.33, then you cannot directly do that upgrade. It is a sequential upgrade. You first go to the next minor release, then you go to 1.33. Even if you try to do that, that path is not directly supported. Hence, it matters that you are doing the upgrade step by step. Next point is order matters. You first upgrade the control plane and then workers. Within each tier, upgrade one node at a time for production. So in our scenario, we have a control plane node and we have two worker nodes. We'll first upgrade the control plane, then we will upgrade worker 1, and once worker 1 is working all right, only then we move to worker 2. Then here is the version skew. I want you to know one thing. See, we are using kubeadm for our upgrades, and we will choose to upgrade all the components simultaneously. So all the control plane components along with kubedns and kube-proxy. However, there could be certain scenarios, certain corner cases where you might want to only upgrade certain components at once. In that scenario, you must ensure a safe rule of thumb which says never run a component newer than the API server. So essentially, your API server should be running a version higher, not lower than any other components. And I will let you read rest of it in this documentation. But again, when you are dealing with production implementations, you will typically upgrade all of these at once. But I want you to understand one caveat. kubectl client is often in your laptop or in your jump host. So you must ensure that it is in line with the version of the API server. Now, why I am mentioning this separately is because you could be dealing with multiple clusters in production implementations, and some clusters could be running a different versions and some could be running a different version. In that scenario, ensure you kind of have a balance between which version of kubectl you wish to use. And if you have such scenario, then what you can do is you can have multiple kubectl binaries in your jump host or in your laptop, and then decide different aliases for them and use them with the appropriate cluster. So keep this thing in mind, and this is an important part for admin laptop CI images. Staying on n or n+1 is practical. On nodes, match the nodes kubelet to avoid drift. So ±1 minor of the API server. And in case you are not able to adhere to this, you can use multiple kubectl binaries. Now let's see why upgrade matters. First is security and compliance. We all know this. Second is features and APIs. For example, if I talk about 1.33, there is an important feature which can perform vertical scaling of pods without a restart. Hence, you do these upgrades to leverage those features and APIs. Lastly, ecosystem compatibility. Maybe the CNI or CSI that you are using does not work with the Kubernetes version you are currently running. In such scenarios as well, you will have to upgrade your Kubernetes version. Now, let's see a high-level upgrade flow that you will see in production implementation. But I want you to understand that each environment is different. Each environment is subjective. The requirements are subjective. So your environment may need some more steps or few less steps. It all depends on your implementation. So here I am giving you a generic flow. First is pre-checks. Verify control plane and etcd health. Ensure capacity headroom. For example, if you have 3 worker nodes and 3 worker nodes are already at 80% utilization, then you will have to have extra headroom capacity so that you can upgrade your worker nodes. So ensure that your worker nodes are at a healthy utilization. And if taking one node out will disrupt your workloads, then always add a node before performing these upgrades. 1 node, 2 node, these things are subjective depending on what sort of load your cluster is withstanding. Second is control plane, one node at a time. Now there are on-premises implementation self-managed clusters which are using multiple nodes for control plane. This is called HA. In that scenario, you will have a different upgrade path. For example, when you have multiple control plane nodes, then what you do is in the first control plane node, you run this command, you apply the upgrade. In the remaining of them, you just do kubeadm upgrade node. Now these things are just commands right now. As we move on to the demo section, all these things will make sense. Workers, one node at a time. We will be using cordoning plus draining. We will be discussing pod disruption budgets. What are these? And then finally ensure that the components that you are using, because your application is not just using Kubernetes, there are monitoring tools, there are security tools, backup tools, CNIs, CRIs, CSIs. You must ensure that while you do this upgrade, all of those things are compatible with your existing tooling. In case it is not, then after the upgrade those things will not work. So you must ensure that all the components are working before you step into upgrading your production grade cluster. So essentially you will be doing all these testing in your development environment first, then you will be doing these things in your staging environment or your pre-pod environment, but ensure all these things are done before you make any changes in the production environment. Post validation check node server client versions, component health and logs, run synthetic traffic probes, and revert any temporary scale out. So this is just validation. Once everything is upgraded, you test that everything is working as expected. Most of the production workloads will have a script that will run a health check to ensure everything is working fine at infrastructure level. Then your application teams will also perform their validation and give you a go ahead. Okay, DevOps team, my applications are working fine. You can make this upgrade as a successful one and then do a small party. Upgrade strategies is next. Now, all at once, this is acceptable for dev and test clusters which do not have any service level objectives. Then you have a rolling. This is the one that we will be doing in this demo, that is one node at a time. Blue green, I will touch this briefly. What happens is, let's say you have 5 worker nodes associated with your control plane. You upgrade your control plane and then you add new worker nodes to your control plane. Now how many nodes you add? You add the same quantity of worker nodes that were associated with your cluster before, and these green nodes that you have added, they are running with the version that you desire. And once this green nodes are added, only then you remove the blue nodes. Now this is a costly deployment style because you have to have the similar infrastructure ready. Hence you will see this in extremely critical workloads, but in general use cases for the Kubernetes cluster and for worker nodes, you might not see this, but the applications that are running inside your cluster, they could follow blue-green deployment model, and there are ways via which you can do this in Kubernetes cluster, and we will see this when we discuss different deployment strategies. But from a cluster perspective, you will not see many production environments using blue-green, but again, critical environments could be using these because there are always exceptions, there are always use cases which warrants something special, but again, this will have higher costs. Now with all this understanding, let's move to the demo section. And what we will be doing, we will be upgrading Kubernetes 1.32.8 to 1.33.4. Now the scope and assumptions, the assumption is only one right now, that you have a working Kubernetes cluster which is one minor version below what I am using. I will be upgrading to 1.33.4. If you want to follow along, then you should be using 1.32. This patch release could be any, but if you have followed my day 54th lecture, then you are good to go as is. Now first is prerequisites. As I told you, we must first verify that whatever we are doing is compatible with the external tooling or the tooling that we are using to support our application. So here I want to check whether what I have in my cluster is compatible with the version I am upgrading to. For example, I am using Calico 3.30. So I must ensure that my implementation will be compatible with this version. And if you see this screen, version 3.30 is compatible with all these Kubernetes versions, and we are upgrading to version 1.33. And then I also want to see the CRI compatibility. Now if I go to my terminal, what I can do is I can run containerd -- version. This will show me the version of containerd I am using. Containerd is the container runtime we are using. It is 1.7.27. So if I go to the documentation of containerd, then I will see that this containerd version that I am using is compatible with version 1.33. And if I see here, you see 1.7.24, anything above 24 is compatible, and we are using 0.27, which is of course compatible. Next I want to see is capacity headroom. So we are running a few pods, but the capacity that we have right now, 2 worker nodes, are sufficient. PDBs and probes pod disruption budgets, we will see them as we progress, and there is a use case for that. This is a backups step. Now before you upgrade your cluster, you should always take a backup of everything that is running. So all the manifests should be backed up. Ensure you do not have single pods running, because single pods are not managed by any deployments. If they are killed, they are killed, they are gone, they won't be restarted. Ensure you do not have any orphan pods which are not part of any deployment. Then you must ensure that you take backup of your HCD. It is of paramount importance. Now the documentation clearly says that Kubernetes upgrades, they do not touch your data plane, as in they do not touch your workloads, your application manifests. But again, they also recommend that you take backup of everything. So hence I recommend you take backup of everything that is running in your cluster. Then HA specifics. Now if your control plane is highly available, then you will have to follow a different method, as in there is a slight difference between the steps, and I have jotted those points in this documentation itself so that you do not have to go anywhere else in case you have a highly available control plane, as in you are running 2 or more nodes to run your control plane. And here is an important point. Now when we want to check the health of the cluster, and health of the cluster, you know, API server is the entry point to any Kubernetes cluster, and /Redis is the endpoint that you monitor to ensure that your cluster is healthy. So the API fronting LB health checks /Redis must be monitored when you are upgrading your highly available control plane nodes. Now in the API lecture of this course, we discussed about this at stretch. If you want to know more about it, then I will recommend you to go and watch that lecture. So that's about the prerequisites. And again, these prerequisites could be different for you. You will of course have to inform your application teams that you are doing these upgrades and all these things. So I will leave it at that. Finally, let's do the interesting part, that is, let's upgrade the control plane nodes. So what I have is, I have two tabs. The first tab has the control plane, the second tab has worker 1 and worker 2. So first tab is where I will be running the commands that are specific to control plane. So let's go here and see what we want to do. So if I copy this command, let me first copy and then I'll tell you what we are going to do. I'll paste it here and I'll press enter. So what you see here is, right now the repository that apt is using for kubectl, kubeadm and all the packages related to our Kubernetes implementations, they are coming from version 1.32. Now what we want to inform apt is a package manager in Ubuntu. What we want to inform apt is, now I am ready for an upgrade, hence anything that I do related to apt should be working on version 1.32. So if I am trying to upgrade kubeadm or kubectl, you should not be referring to this repository, because this repository only has packages associated with version 1.32. I want you to look at the repository that has the packages for version 1.32. Hence what I will do is, I will vi this file. I'll hit control, I'll first remove this, I'll hit the up arrow, control A to move at the front of this, and then what I will write here is sudo vim and this file. I'll press enter and I will go in the insert mode, and then what I want to now do is 1.32, I want to change this to 1.33. Now in case you are on 1.31 and you see 1.31 here, you should not be writing 1.33 directly. You should first be writing 1.32. Once you perform that upgrade cycle to 1.32, only then you move to 1.33. So for now I'll just do 1.33. I'll hit escape shift ZZ to save this file. This file is now saved, and then I will go to my browser. And this step we have already performed, and let's move to the next one and determine the exact target version is what we want to do in step 2. So what we are doing is sudo apt get update. This will refresh the index in accordance with the newly configured repository. Let's copy this first and then I will paste it in the terminal. I'll press enter. This will update the index. Then I will do sudo apt cache Madison kubeadm. This will show us all kubeadm versions available at our disposal. So this is interesting. So let's go here. I'll run this. Now I want you to see one thing. It is saying that with this repository, the repository that we just added for 1.33, you are free to go to any of these versions. Now, like I told you, in production environments, if you are going to the latest minor release, you might not want to go to the latest patch release, so you will be changing that accordingly. But in our demo, we will be choosing this. So this command will give you a very good summary of what all versions are available in this repository. Now, not what all versions, what all patch releases are available in this repository. So this repository has everything 1.33 from 0, patch release 0 to patch release 4, which one is the latest. So we'll go back to the repository again. Then I will do this command and I'll tell you what we are doing. I'll paste this here. Now we are saying unhold kubeadm. So what you will see in production implementations is whenever you are dealing with any of the Kubernetes related binaries. So for example, there is kubeadm, then there is kubectl, then there is kubelet. You do not want anyone to come into your control plane node and upgrade these. So what I am saying is, if anyone is running apt specific commands, if anyone runs a command that upgrade every package, then you do not specifically upgrade kubeadm. So that is what a hold will do, and it is an important part. So whenever we are done with our installation, everything is done, you put a hold on these things. So what a hold will do is it will pin the version that you have right now, and if anyone runs these apt upgrade commands, these packages will not be upgraded, and that is what we want. We only want these packages to be upgraded when we are doing the cluster upgrade. So we want things to be predictable, hence we put a hold. So right now, since we want to upgrade the kubeadm version to the latest, which is 1.33.4, hence I am unholding it right now. So cancelled hold on kubeadm. Now let's run the next command. So in this command, what I am saying is apt get update, apt get install. I want you to install this version of kubeadm. And how do I know I want this version? Because I ran this command. That is why I know I want this version. So always understand what are the repercussions of the command that you are running. Do not follow the steps blindly. If you have any questions, any doubts, search the web. If the web is not helping, ask me in the comment section. Maybe I'll have an answer for you. Now let's go back. Now I have upgraded my kubeadm, so I will put the hold back first and I'll paste it here. So the hold is again there. So now I can run kubeadm version. So this will tell me the version of kubeadm that I am using right now. I'll have to spell it right, kubeadm version, and the version of kubeadm is 1.33.4 like we expect. Now let's go back to our repository and see what the next step is. Plan the upgrade. Understand, this is like Terraform plan. This will not do anything. This will just tell you what should you expect. So I'll copy this, I will paste it here, and this will tell me what is that will happen if I go ahead with this upgrade. Now, important thing. Components that must be upgraded manually after you have upgraded the control plane with this command. So we'll be running this command next. So what it is telling you is kubelet must be manually upgraded, and also kubectl client will have to be manually upgraded. The things it will be upgrading, the kubeadm utility will be upgrading, are these things. Now I want you to observe something. Whatever kubeadm is not upgrading for us, they run as services or they run as binaries. If I talk about kubelet, it runs as a service, and similarly, kubectl client is also a binary that you use to connect to your cluster. Hence, kubeadm is not touching those things. So kubeadm is only upgrading the things that run as pods. So if you see all of these components, they run as pod, and kubeadm is only upgrading those components. Now I want you to contrast this with your application upgrades. So if your application is right now running version 1 and you want to upgrade your application to version 2, what you do is you create a new Docker file, and from that Docker file you create a container image, and that container image is version 2, and then you deploy that image into Kubernetes and your application is now running version 2. As simple as that. That is what you do to upgrade your application. Now come back to Kubernetes. What you are now doing is you are upgrading your control plane components. Then kubeadm at a very high level, what it is doing? It is just upgrading the images that are there for these components. So for example, API server has a manifest file. In that manifest file, if I change the image to the latest one, then I am running the latest version of kube API server. Similarly, for all other components. And I want you to know that 4 of these, API server, controller manager, scheduler, and etcd, they are running as static pods. So if I cd into etc kubernetes and then I hit ls, we know that the static pod manifests are saved in this manifest directory. So what I will now do is I'll sudo cat manifests, and then here I want the manifest for API server. Let me first hit ls here. Let's do ls, and I'm not allowed to do that. Let me add sudo here, and here is the manifest for our API server. So let me do one thing. Let me cat on this manifest. I'll write manifest here, then I'll add this and I'll hit enter. Oh, I'm not supposed to open it. Let me add sudo here. And here is the image that this manifest is using. So understand that my Kubernetes API server is right now using version 1.32.8, which is the version that we are running right now. And when we upgrade our cluster using kubeadm, essentially kubeadm will replace this with the new image tag, and similarly it will add few more parameters here and there which are associated with this version, and it will do the same steps for other components. So I want you to create a mental map with me when you are working in such scenarios. So let me clear my screen. I will again go back to my home directory, and then I will run the same command again so that we can see a few more things. So these are the target versions where all these things will be upgraded to. So let's go back to our browser. I will copy the next command that I want to use. Plan we have already done. Then I will go to step 5. Step 5, we will be applying this. I'll copy this and then I can paste it here. I'll press enter, and this has started doing its magic. So I will say, yes, I want to upgrade. So here it is saying, this is your current cluster version. This is your kubeadm version. You have chosen to upgrade the cluster version to 1.33.4. I'll say yes, we want that, and this will do its magic. Now I want you to again understand what it is doing. It will change all the versions in the static pod manifest files to the version that we want to use, that is 1.33.4. So let's go back to our GitHub repository and see what we want to do next. Now once it has done its job, we will be verifying using kubectl version and kubectl get node. So let's go back here and wait for it to complete. And you can see here what it is doing. It is backing up our previous manifest so that if we choose to do a rollback, we can refer to these. Now it is doing the same for the kube API server, what it did for our etcd's YAML. See, now you would be wondering about why this path, but again, if you have any confusions about this, you go to the static pod lecture. I will link that in the description as well. So the reason why these typical complex topics like cluster creation or cluster upgrades are placed at the very last of this course is because so that you have all the understanding to understand the concepts that are required to fully grasp what we are doing. So in case you do not understand static pods, then you would be wondering what this path is. So for now, just understand that your control plane components, they run as pod whenever you set up your cluster using kubeadm, and the manifests for the static pods can be found in the path that you see on your screen right now. And you see it has now moved to upgrading the kube controller manager. So the sequence is, it first did for etcd, then kube API server, then controller manager, and finally it is dealing with the kube scheduler. Okay, the control plane node of your cluster was upgraded to 1.33.4. 4. Now let's see what we want to run next. We want to run kubectl version. This will tell us the client version of kubectl and the server version. So the client version is still 1.32.8, which is we expect, and then the server version is 1.33.4. So this is how you do an upgrade for your control plane. Now let's run kubectl get nodes. I want you to clearly understand the version that you see here is for the kubelet, and the kubeadm utility explicitly told us that I will not be upgrading kubelet. You will have to do that on your own. So let's see what we want to do next. So in step 7, upgrade node local bits on the control plane node. So first I will unhold both kubelet and kubectl, then I will upgrade them to the required version. And why I can do that? Because I added a repository that has all the packages 1.33. Then finally, once the installation is done, I will perform a reload, and then I will again put a hold onto these utilities. So I'll copy all these commands from here and I will paste this onto my control plane node. So you see, canceled the hold, and then it is performing the upgrade. So once the upgrade is done, I will again put the hold. kubeadm was already set on hold. Now I will run kubectl version again, and you will see that our kubectl client is also upgraded to 1.33.8. Let's allow it some time. It is not displaying the server version right now. Client version is 1.33.4, which we expect, but the server version is not displayed because kubectl client cannot connect to our API server. So let's quickly run kubectl get pods to see what's wrong. So kubectl get pods is running. As you can see, I already have 10 pods. And now let's run kubectl version. This should succeed now. Maybe there was a temporary glitch, and now you see both our client and server are running version 1.33.4. That is what we wanted. And finally, let's also check kubectl get nodes and verify the version of kubelet as well. And you can see the kubelet on our control plane node is on 1.33.4. That is what we wanted. Now we are done with our control plane node. So let's go to our worker node and do our magic. So let's come here. And here I have given some pointers about HA clusters. I will let you read those, but the crux is you perform the upgrade on your first node, and after that what you do is kubeadm upgrade node. This is the command that you use. So just give it a read. Now worker node upgrades one at a time. Now first command is kubectl Cordon worker 1. And then second command is kubectl drain worker 1, ignore daemon sets, delete empty dir data. What does cordoning mean? So firstly, cordon is when I cordon a node, the scheduler will take it out of the scheduling algorithm. It will not schedule any new pods onto that node, but the existing pods that are running on the cordoned node will continue to work fine. So if I go to my terminal again, I will run kubectl get pods and I will add -o wide here so that I also know on which node these pods are running. You see, these pods are distributed amongst worker 1 and worker 2. So now let's do one thing. I will copy this command and I will just paste this command here. Okay. And once I do that and I run kubectl get nodes, you will see that this node is ready, but scheduling is disabled. Why scheduling is disabled? Because I just cordoned this node. So if I now run kubectl get pods -o wide, I will see that my pods that were running on worker node 1 are still working. Okay, so this command just disabled scheduling of new pods onto this node. So let's go back and see what will drain do. Now the drain is something that respects pod disruption budgets. We will see what these are. Now we know that our worker nodes, they also run daemon sets. So if I go here and I run kubectl get pods -n, I'll write -a because I want to see all of them, and then I will write here -o wide and press enter. If you see, worker 1 is not only running our workloads, worker 1 is also running, if I scroll up, it is also running the Calico node, it is also running the CSI node driver. So these are daemon sets. And if I run kubectl get ds -a, then you will see that all our nodes will be running these kube-proxy pods and Calico node and also CSI node driver. So all these pods are also running, and we explained what are these in our previous lecture in day 54, so you can watch that. But for now, I want you to understand that our worker nodes are not just running our web pod, they are also running daemon sets. So here what I'm saying is, when you drain this worker, what does draining mean? Draining implies that this node, whatever workloads are running here, they will be kicked out immediately. And we are saying you also kick out the daemon set, which is why we have added -- ignore. And same we are saying for mtdir data. So what I'll now do is I will copy this and then I will paste it here. I press enter. And just like that, it evicted all my pods. Is it fair? As a DevOps engineer, you would be saying, yeah, Varun, it is fair. That is what we wanted. But is it fair from application's perspective? Maybe the application that was running here wanted 10 pods to be running at all times. And maybe the remaining worker, that is worker 2, will not be able to withstand those pods, may not be able to run those pods of XYZ reasons. Maybe the load on worker 2 is so much that it cannot run more pods. But my application, which was running here, wanted 10 pods at all times. And this command, draining the node, it just kicked out everything that was running in that node. So is there a way to prohibit it? Yes, there is. And that is where pod disruption budgets come into play. So let's briefly understand that. I do not have a demo for you right now on pod disruption budgets. We'll have that later. But for now, I want you to understand there is a way via which you can ensure that when I am talking about this application, I want this application to always have these many pods. So if your application requires 10 pods at all cost, then you can achieve that using pod disruption budget. So what will happen is, if you try to evacuate a node using drain command, then if that application has PDB set, pod disruption budget set, then Kubernetes will not allow you to drain that node. So let's understand this in a diagram. So I'll go to my diagram section, and here is what we just did. So we were on worker 1. As soon as we ran our drain command, all the pods that were running in worker node 1 were evicted. Now I want you to imagine there are two deployments. One is red deploy and second is green deploy. Now green deploy is not that important for me, but red deploy is extremely critical for me. Now I want that my red deploy should always have 3 pods running. But as soon as Varun ran this command on worker 1, all these 3 pods along with the daemon sets that were running were kicked out immediately. And when that happened, I only had 2 pods in my red deployment, and that is not something I want. I want 3 pods of red deployment should always be running. So what I did is I came here. What you see here is, here on the left is a manifest for my red deploy, which says I want 4 replicas. Like you see, we have 4 replicas for red deploy, which is fine. Then what I also did is I created a pod disruption budget, and in the pod disruption budget, what I said was the minimum available for the pods that have app is equal to red deploy label, and here the pods have app is equal to red deploy label. I want the minimum available pods for any pods that match this label should be 3, which implies if I run this command here, then these pods should not be kicked immediately, because what I want is I want 3 red pods to be always running. And if all these are kicked simultaneously, then that condition will not be met. So once I apply both of these manifests, once I specially apply this pod disruption budget, then it is responsibility of Kubernetes to ensure that this red deploy always has 3 pods running. So let's see what will happen. I have 2 scenarios for you. Scenario 1, worker 2 has enough capacity. When Varun runs this drain command, what will happen is only 1 red pod will be evicted, because 3 must always be running. And once the evicted pod is recreated on worker node 2 or any other node and is in ready state, only then this pod will be terminated. So Kubernetes will ensure that you always have 3 pods for this red deploy. Then second scenario is worker 2 doesn't have capacity. Now let's say first pod was terminated, and it was terminated gracefully, and it will do that because you only want 3 pods to be running at all times. So 1 pod will be terminated. But when it comes to the second pod, and if there is no capacity in your cluster, let's say you only have 2 worker nodes and worker 2 is already full, in that scenario, this pod will not be evicted. Hence, worker node 1 will not be drained, and you as an administrator will not be able to perform that upgrade in worker node 1 until and unless you ensure that the red deploy has enough pods, has 3 pods running. So keep this in mind. As administrators, you will often be configuring pod disruption budgets to ensure the critical workloads that require a certain amount of pods running at all times are not disturbed because DevOps team decided to upgrade the Kubernetes cluster. So keep this thing in mind. Now, I want to highlight one more thing. If someone powers off this worker 1, then pod disruption budgets will not be adhered. So these are only applicable, or these will only help you when there are planned outages, planned downtime, not when someone deliberately powers something off or deletes something. I want you to understand that we discussed pod priority and so many things in our previous lectures. Pod priority was helping us during the scheduling time, but once the pod is running, these priorities are not considered. Hence, pod disruption budget are must to be configured. Now, I brought this topic here because when you are facing interview questions or working with real-time production scenarios, you will be asked these things. How did you ensure during your cluster upgrades that your application continued to work fine? And this is one point that you can always mention. First is I will do step-by-step upgrade of 1 worker node at a time, and then second one is I will ensure that pod disruption budgets are in place for critical workloads so that my application teams do not raise complaints for our DevOps teams. So let's go back to the GitHub repository and run the commands that we want to run. So we have drained our worker 1 now. Now we want to upgrade it. So I will simply copy this, and we have already seen these commands. So first I will add 1.33 as our repository. So I'll copy this. I will go to my terminal. I will go in this tab. Now I want in worker 1. I will increase this size a little. I will paste this here. I will hit enter. I will go into insert mode. In place of 1.32, I will add 1.33. So I will add 1.33 here. I will hit escape, shift ZZ to save this file. I'll go here. I will now copy all of these things. I'll copy this. I'll paste it here. I'll press enter. Then I will see what I want to do next. As simple as that. Your worker node is upgraded. So what we did is we first put an unhold on kubeadm, kubelet, and kubectl. steps are common. We did this also in our control plane node. And then here what we are saying is install this, and then once the installation is done, we are again putting a hold. Holding things are important, and I want you to know that the Cordon command, the drain command, we ran from the control plane node, because it is the control plane where we have our kubeconfig file. In worker 1 I only ran these commands. Now I will again run these commands from our admin shell, and for us our admin shell is our control plane node. So I'll go here, paste these commands here, I'll press enter, and worker 1 is uncordoned. So what I have now here is worker 1 is now running version 1.33.4. If I now run kubectl get nodes, similar to this, you can see the succinct output here. I can also run kubectl get pods -o wide, and you will see there are no pods running in worker 1 right now, because these pods are already scheduled here. Now people who are here from VMware background, I want you to understand, you could vmotion a virtual machine from one host to another, but pods cannot be vmotioned. You cannot move pods from one node to another. You kill the pod and then it is restarted onto the same node or onto any other node depending on the scheduler's algorithm. There is no live migration of pods from one node to another in Kubernetes. So keep that in mind. Now only workloads will be scheduled in worker 1 once I Cordon worker 2 for our next demo. So what I will now do is I will again go here, I will copy this command, and then I will come here, I will paste it here, and then I will write worker 2 here. I'll press enter, and then what I can also do is if I directly run this command, then it will automatically Cordon. But I wanted to show you the difference between Cordon and drain, hence I wrote both of these. So I'll copy this as well and I'll paste it here, and here instead of worker 1 I will write worker 2. So worker 2 is now drained. So now our pods should be running in worker 1, which is already upgraded. So I will run kubectl get pods to ensure that our worker 1 is behaving as we expect. I will hit enter. I will also have to add -o wide, and you see my pods are working just fine in worker node 1. Now understand, in production implementations you will only uncordoning a node once everything is working as expected, and once you uncordon you will try to schedule new pods onto it and see whether they are behaving all right or not. Only then you would want the production workloads to be running onto your upgraded worker nodes. So I will go back here and then I will run this in worker node 2. I'll copy this, I will go here, I will go to this tab, I will go to worker 2 now. Here I will paste this, I'll hit enter, I will go into insert mode, and then what I will do is I will quickly make this 1.33. And once this is done, I will come here, I will copy all these commands and I will paste them here. I'll press enter, and we already know what these commands are doing. And once I am done here, I will quickly see, once it finishes, I will uncordon it. I'll go to my first tab now. I will run kubectl uncordon worker 2. I'll press enter, and now I will run kubectl get pods, and I will write a -o wide here. There will be no pods in this node, but what I want to show you is kubectl get nodes, and here you see all my worker nodes are running 1.33.4 of kubelet, and hence everything is working smoothly right now. So what I can now do is I can write kubectl scale deployment, and the deployment I want to scale is named web, and I want to scale this to 20 replicas. And if I do this, and if I run kubectl get pods -o wide, I see the pods are also being scheduled onto worker node 2. Now, before I perform the final validation, what I want to do is I want to restart this node. So I will write sudo init 6, and here as well I will write sudo init 6, and then I will do the same for my control plane node as well. My connection is broken, hold on. Yeah, and I'll check this one as well. Now I'll go to this tab. Here as well I will do sudo init 6. So I should have rebooted control plane once I was done with the activity. It is always good once you are doing an upgrade, you restart your nodes so that everything stabilizes. Worker nodes should have already come up. So worker 1 and worker 2 are already up. So I am in the control plane node. Let me hit up arrow and log in again. I'll clear my screen. I will run kubectl get pods, and here all our pods are in running state. They only have had one restart, which is expected. The restart happened because we rebooted our node. That is fine. Now I will run kubectl get svc, which shows that I already have a service which is listening on 304.3.8. So I will go to my browser. I will go to this console here, AWS console. I will copy the IP address of this worker. I will write http:// I will paste this, and the node port was 304.3.8, 304.3.8. I'll press enter, and voila, we see welcome to Nginx. And let's do the same with worker node 2. I'll copy this. I will write http:// I'll paste this here, and it is 304.3.8, 304.3.8. I'll change that https to http, and then I'll press enter. And here also welcome to Nginx. So everything works as we expected. Now again, if things are not working for you, allow it some time to stabilize. So first is you reboot your servers after the upgrade is done, then you allow it some time to stabilize. I had stopped the recording because we were able to access the Nginx service just fine over our NodePort. But later, after I was just doing a quick sanity check again, I realized that the Calico node pods, these are in running state, but their status is not ready. So what I did was I troubleshooted this further, because Calico node is your CNI pod and it runs as a daemon set, Calico node, and it is critical for the workings of the CNI. Hence we want that this pod should be in ready state. Right now it is not, which is a concern for us. Even though our web pods were accessible, they were in running state and we were able to access them over the web, but this problem must be fixed. So what I have done is I recreated a cluster, upgraded that again to replicate this scenario so that I can troubleshoot this along with you. So I have already done initial troubleshooting, what the cause is and how to fix it. So let's walk through on what was my approach to fix this problem. Firstly, I saw it is not in ready state. The first thing I did was I did a kubectl describe pods -n Calico system. Then here I copied this pod name. I can do that for any pod, and then I pasted it here. And when I pressed enter, I saw that there is an error that says bird is not ready, error querying bird. Now this error pertains to BGP, but then I thought to myself that BGP is not something that we are using. As I discussed in day 54 of this lecture, we are using VXLAN that does not use BGP, and accordingly we opened our ports. So for now this error is there because TCP port 179 is not allowed, which is used by BGP. But in our scenario, we do not need BGP. So there must be some way via which I can disable BGP. And this is something that is also recommended by Tigera, by Calico. They have not explicitly done it here. I'm not sure why, but if I go to their documentation, they say here, when you are using Kubernetes VXLAN, ensure that BGP is disabled. And you read these two lines as well. If you installed Calico using the manifest, that is not using operator, then BGP is already disabled. But what we did was we used operator, which is the recommended approach to install Calico. Hence, for us, BGP was automatically enabled. So we do not want that. First, let's do one thing. Let's disable BGP. Now I will go to my GitHub notes. I have added another section here, which is called Calico post upgrade troubleshooting. So I'll click here. I will also zoom in a little, and here is the way which will tell you whether BGP is on or not. So I'll copy this and I'll go to my terminal and I will paste this here. And when I do that, it says enabled. Hence, BGP is enabled in our cluster. So let's do one thing. I will disable it using this patch. So I recommend you also run this. I'll copy this and I will paste this here. And another thing I want to highlight here is I will add this note in day 54 lecture as well, so that the folks who are watching that lecture can do this thing right away. Because even if you have a newly created cluster and followed the instructions I gave in day 54, then day 54 cluster would also facing this problem, because we used the settings that are available by default in Calico's documentation, but we do not need BGP. Hence, we should create our cluster using these settings itself. Now, if you have already done this in day 54, because I would have added this as steps in day 54 as well, then you do not have to do it after the upgrade. Your cluster would be working fine. But for folks who have not done this, I am mentioning this here itself. So I will copy this, and it says that it is patched. Now, once the patch is done, I want to do a rolling restart of Calico node daemon set. So I'll paste it here and then I will do a rolling restart. I think this screen is in hung state. I'll press Ctrl C and let me run kubectl get pods -a. Now, if I run this again, you see that 2 pods are working fine, and still there is 1 pod that is not working. It is not in ready status. I will copy the name of the problematic pod. Then what I will do is I'll do kubectl logs -n Calico system, and then I will enter this here and I will paste it, and this will tell me what is going on with this. It's saying reporting non-ready. So if I go up, and this is pertaining to Felix, it is saying Felix is not able to start up because port 5473 is not allowed. Now, but Varun, we were not using 5473. You never mentioned in day 54. What happens is there is a component called Taifa. You typically will not require that component because that is only needed when you are dealing with extremely large clusters, because Taifa is something that acts as a caching solution. It acts as a fan out solution. But in our installation, Taifa came in by default. If it came in by default, we should make it functional, or we should just remove it altogether. So what I opted for was I opted to keep Taifa, so that anyone who is dealing with a production implementation that uses Taifa can also benefit from this. So Taifa requires port 5473 between all your nodes. So between your worker nodes and between your control plane nodes. So if I now run a describe on this pod, which is not in ready state, I can write kubectl describe pods and I press enter, you see that it is saying that readiness probe failed, Calico node is not ready, Felix is not ready, readiness probe reporting 503 error. So let's do one thing. Let's go to our browser and I will go to the security groups section and I will go to the control plane security group. I will edit inbound rules and I want to add a rule for TCP port 5473 and I want to allow this from data plane security group. I will save this rule and then I will go to the data plane security group, and here also I will add two rules here, one for inter-worker communication, one for the communication from the control plane. So I will add 5473 here, and the source will be first from itself because two workers could be communicating with each other, and then I will add one more rule and this one will be from control plane security group. I will save this, and as soon as I do this, that communication will start to work fine. So let's go to the terminal and I will again see kubectl get pods -a, and see it is now in initialization stage. There are init containers for this which are now running. So let's again run this command and you see it is still not in ready state. So let's allow it some more time. It's still not in running state. I will run this again, and now the status is all good. Now all our Calico node pods are working fine. I want you to know that Calico node runs as a daemon set, and this is actually the pod that is doing all the legwork in your nodes. So this pod must always be in healthy state. And lastly, I also want to quickly verify that our page is still accessible. Since this is a new cluster, you know, my NodePort has changed and my service is accessible on both of these nodes just fine. And I think that is all I wanted to cover in this lecture. We switched to the 1.33 repo, upgraded kubeadm, ran plan, apply, bumped kubelet, kubectl, and rolled workers with Cordon, drain, then confirmed CoreDNS, kube-proxy, and other components are working as we expect. You now have a clean, repeatable upgrade runbook at your disposal. In the next lecture, we'll be discussing Kubernetes logging and monitoring. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.